Awesome. Here, we're going to just start the stream here.
Yeah, I'll
What I'm doing is I am creating another one of those setups right there. Keep the camera away from the magnet, please. Thank you. Yeah, I almost do it all the time myself. This might not be good. I think it's good. If it didn't start drying before I got it on there, it's right where it needs to be.
nice. I'll stand back.
Give it a little bit of time to dry.
That looks sweet.
And what it's going to do is it's going to hook to this motor that's over here that I had stashed away. Just like this one is hooked to it right now. You can see it's starting to spin that aluminum disc. We're going to have it spinning like that, except I'm going to have like a gyroid of aluminum going around the outside of it. We're going to see if we can't get a counter rotation or just a synced rotation would be good for me. We can probably get that aluminum disc going pretty fast.
Yeah.
We're at 3 volts in, 3.13 in, 0.5 of an amp, half an amp. Very cool. Yeah, I'm a little anxious myself, but that's moving pretty good. So I think this gyro thing that I'm thinking of is going to work just fine. You know, it's gonna spin. Both of them are going to spin. I'm going to try to have the bearings good enough so when the shaft spins, the outer ring doesn't spin, but it's going to be on the same shaft. I mean, you'll get what I'm trying to say. It's so neat. Cut it back. And it comes to a stop. See, this is very well balanced rotor right here.
Indeed.
Yeah, it can spin a lot faster. That was just 4 volts. It's a standard 12 volt motor. It can spin up to 3,500 RPMs. So I was planning on using this shaft and putting like this aluminum around it in this kind of fashion with the bearings. You know, have the aluminum be on the bearings somehow like this, so it could spin the opposite direction.
I can't see it.
Can't see the bearing? Oh, you still can't see it. There it is. So, and then we want to have them away from the. This is where it's going to get tricky. I need some kind of maglev for the aluminum, and that's why I think I'm going to have to build a former to put the aluminum on and attach a maglev to that. So, yeah, and then the former will see the bearings. Let's see how balanced this one is right now. So it's not totally perfect, but I bet if we spin it, oh yeah, that's way off. You can't really tell until you put it on this thing. It's all right. No, that's terrible. Yeah, it's not good. I'm probably gonna have to redo this one or make another one, but that's all right. It's just a concept right now. And then gonna have a former that'll go around. It'll be virtually just a ring, a flat ring of aluminum that'll go around this thing, and then it should spin. And yeah, and then the aluminum should either spin with it or spin counter rotation. I thought that was going to end up better than it did. This one here is pretty good. It's just the shaft is spinning. This one here is like almost perfectly balanced. But look, see how short the shaft is on the other end? I couldn't get the ring on there if I wanted to. But yeah, I mean, this one's good. This one is good for proof of concepts. Like for instance, the fact that when I do hook that up and get the aluminum ring going around the outside, that ring is going to spin. If I set it up right, it's going to spin without the help of an electromagnet. Permanent magnets. And if I wanted it to go fast, we hook it up to a motor. And then, I mean, I'm using a DC motor currently, just to stand something out of a catalog. I mean, this you know, this bipolar thing, just one north, one south. So one north, one south. It's actually two norths and two souths, but they're stacked together, so it's one north and one south. But you do have that little bit of a piece of plastic in between, so you can say there's definitely a separation there. So it could be just 2 and 2, and keep it simple. But this one is 6 and 6, spread a different way. And it's north, south, 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 north. You get the point, right? This can spin the disc as well as that, or better than that.
Right.
All right. So I'm going to turn that on again. And then we might move it over to this and then switch the power around here real quick. 5 volts. See, like, this is where I started. This is how I started. I've had this motor forever. And I'm not afraid to use a DC motor. So I'm not faking anything. Oh, yeah. Because the concept is right there. And the magnetic interaction between the aluminum and the permanent magnet, you get motion. And I believe it's counterclockwise to clockwise, so I believe it's counter rotation being displayed here. But I don't know, because counter rotation is kind of defined by there being an electromagnetic presence. And you're basically pushing off of one another based on a timed situation. But I mean, this could easily be timed too. If it's north-south is on-off, the duty cycle's 50%, and there, I mean, you got your frequency. I wonder what that would be, actually, the frequency of this aluminum rotor. Wouldn't be very much right now, but it's still moving pretty fast for it just being pushed around by a little bit of magnetism. It's all good. It just got a little bit too close there. And that's why I have the aluminum disc is fatter than the total range of the toroid magnet, so it'll never hit the outside edge. It will always ding it like a bell. And that's good safety right there. I mean, if you don't have a freaking cage you can put around it, that the bell is about as good as you're gonna get. Because it's not level. Okay, and I just threw this together like that. I'm like, that's what I want to see, if it works or not. So I just made it so it would happen, so I wouldn't have to hold it, because holding it sucks. Sitting there holding it sucks, man. You need your hands. There you go. All right. So what I want to do now is I want to move this apparatus over to there, and we're going to turn that on. Here, let me do this right now. We're going to move the red to the red. And we're going to move red to the black. All right, we're going to run the middle one. I had it on 10 volts this morning, and I got it up over 1,000 RPMs. I don't know what it'll do right now. It's kind of sporadic on how fast it's going to go. We're going to get it going, and I'm going to move the aluminum disc up next to it. See what we can get out of it. Alright, 10 volts. If it's even hooked up. Let's see.
Sounds good.
North-south. That's north-south. Only drawing 100 milliamps. That's pretty good. And I want to get this bearing in here. There we go. See, that's still out pretty far, isn't it?
Yeah.
Oh, it's starting to wiggle its way down the pole there. That's not what I want. I don't know if it'll go this low with the load on it like this. See though. You hear how it was triggered already. So it should just sink in. Still sliding down the pole, but I got my eye on it. So far the toroid magnets are kicking butt, right?
Yeah.
It's definitely working. See, I want to get it up closer. But I think right now it'll stop it at this low voltage. But I had it going really fast at this voltage earlier today by itself. I mean, it's supposed to be bouncing back and forth because it's north-south on a diode, a DC rectifier. It triggers on a DC rectifier, so it shouldn't even be moving right now, but it's moving, and sometimes it moves pretty fast. And it's moving with a small load on it. That's awesome. I'm so tempted to just go over there and turn it up, but I'm not gonna go over there and turn it up. Now I had this one hooked up parallel. It draws a lot of current to run this parallel, like three amps at 9 volts. So it's like 27 watts just to run it at 9 volts. There it goes. Hear that? See that? Wow, there it goes. And that was just creeped up. It's 0.2 amps now. But it definitely did that on its own. It walked its way up there. It didn't start up there. I'm thinking it's going about 600 right now, maybe more. Nope, 438. Oh, it's creeping up though, really fast. Now it's at 470. Yeah, wow, okay, it's in an acceleration mode. second wind.
Mm-hmm. Hey everybody, welcome to the channel. Thank you for dropping in. This is Papa Bale. Drop us a like and subscribe. Let us know if you have any questions.
What's up? I have a new plan for another gyroscope counter rotation mechanism. So that shaft that's right down there in front of you, Chris. Yeah, that one. We're going to spin that, and we're going to have the aluminum go around it like a ring. Just a two-dimensional ring right now. We can worry about other rings in the future.
Nice.
And we're going to see if that little, the toroid, spinning the toroid on the shaft will be able to allow this to spin in the opposite direction, or maybe even in the same direction. It doesn't bother me either way, but it's going to look neat, I think, spinning them together. Oh, see, I think we sped up a lot and the amps went down again. Yeah, almost 500 now. We're starting to go down again. So 492.8. Yeah, we're going down now.
Working with 1 and 2 watts.
And it's spinning this aluminum disc. That's no joke, man. That's quite a break on the rotor. I'm glad it's spinning, or it would be. It would stop it like instantaneously. Yeah, we're slowing down pretty quick now. It's all right. It might be because the rotor's sliding on the pole or something like that. There is definitely a point where these things slow down, but when they get back into the groove, let's call it the groove. If it gets back into the groove, it'll speed up to the point where it slows down again. And then it'll speed up, it'll slow down again. It's more like a range of operations. But I do feel like that disc is getting closer because it's getting really hard to see that tape. But it's moving at this like a perfect speed for me to be able to catch it if anything happens. But the same thing, it's when you line it up to the edge of the aluminum, this thing will never hit the outside edge. It's not big enough. So it won't send anything flying is what I'm saying. But it does make a loud ding. I'm also thinking about maybe making a rotor that's attached to the shaft, similar to these two with the toroid magnets, but making it like a radial toroid, you know, instead of having the two toroids, have like a regular rotor. And then just maybe putting two toroids on the top of that one. So I'll have the shaft be spinning and then have the two toroids spinning on the top here. And then have a bunch of little motors set up around this thing that when it's when the big one spins, all these little ones will spin with it. We'll see how much electricity we can get off of that. Hey Mike, what's up? Hold on a second. You good?
Yeah.
All right, I'm gonna be checking periodically just to see if you're all right.
All right.
All right. So, yeah. So I was thinking about making a shaft, Mike, that's attached to my rotor. Finally, going back. I mean, I used to do that all the time, but now, since I got better bearings, I haven't even thought about doing it. And then having like the toroids on the top, big ones, spinning all the little ones on the bottom. I think we'll get 20 DC volts out of that, no problem. That'd be a huge project, and we'll get like minimal results, and I'll be happy with that. I mean, if we do it right, we could probably get some good output. Put your shirt on. All right. Cool. Kids. All right. So I don't have enough money to get all these printed out right now, but I'm gonna, as soon as I get a spare chunk of change, I'll get the right design and get these printed out. And I gotta get my I think it's called a Toron or something like that. Holds the Utron exactly like that. Okay, like at a 45-degree angle, so that the square edge of your cone is like at a 180-degree thing. So when your C-shaped magnets pass it, you'll get the most out of it. Yeah, a lot of work, Mike. A lot of work. Oh man, the DC motor just popped out of my chest, and I was like, ah! I mean my work chest, not my real chest. Over here, man, this little devil will get this thing going like 2,000 RPMs. What are you doing? Okay. That's good. I don't believe what I see sometimes.
Welcome to the channel. Thanks for dropping in. Welcome to the channel, Vishal.
That's awesome when he drops in, but I think I just saw him take a step on my printer. I'm gonna have to get that off the floor. My fault, 100%. I shouldn't be on the floor. I just don't have an adequate surface to put it on. I mean, this one's on this surface over here, but it moves and shakes and shimmies. It's not a good surface to have it on, and it's right next to the window, which is terrible. Should probably move it to where the fan's at. Put the fan over there by the window. Yeah, it's really not good to have your printer by a window, especially one that you open. With that being said, I feel like I should move it right now, but I'm not gonna. Hello? Yeah.
So that's the reaction you got out of him, Vishal. Thank you for coming to the channel. We are working with pulse motors and
there you go.
eddy currents. That's what's spinning this aluminum rotor right here.
Yep, the north-south interaction with the aluminum rotor, eddy current coming from the aluminum disc. This is a north-south arranged 12 magnet rotor being run by a bifilar coil at 26 gauge drive, 30 gauge trigger sensor coil, and it is spinning at 489.1 RPMs at 10.1 volt and 2.2 amps in. Okay, so we're at virtually 2 watts. So about 500 RPMs at 2 watts. And it's got a load on it, which is this aluminum disc, which I don't know, we'll try and get a reading off of it too. Yeah, I don't think this has a reverse reader, so it's not going to read the black stripe. Oh, there we go. Read something. 432.2. We'll take it.
Wow.
We'll take it.
Nice.
We'll take that. So 500, 400. We're rounding big numbers here, but it's about what it is. So it's definitely being pushed by a force that isn't equal to what it needs, if you get what I'm saying. If this one's going 500 and this one isn't going 500, then that means it's like either far apart, or there's definitely a delay there. This is a 12 magnet. It's a monopolar, all north. It's got this 20 gauge coil, 20 gauge, 20 gauge, 30 gauge trigger, 30 gauge trigger, 30 gauge trigger, hooked up parallel. Takes about 3 amps to run this baby, because it's so close. I mean, these coils are so close to the magnets that it's like max amps. And this is input, max amp input. Alright, sweet. Alright, well, I don't know anymore, man. I don't know how to answer that. I would definitely say I don't believe in free energy.
That's a good stance to have.
I'd say that there's a cost for everything. Even if you can travel around the entire universe and never age a day, there's a cost. There's always the cost. It's part of being reverse engineers, some of us, not me in particular, but people that are presenting things like this online. Reverse engineer things. And I think that, wow, totally lost that thought right there.
Right on, Mike. Cosmos works hard to balance all energies. Yes, indeedy.
No, I mean, even if it presents itself as being a broken law, it's just a law that you didn't understand. That's what it is. You just didn't get it. That could be totally true even for Einstein at this point. You just didn't get it quite right. You know what I'm saying? It's like, if it's a law and there's a boundary that you can't pass, try just redefining your understanding of that law. And you know what I'm like, like this right here. I didn't understand this a week ago. But then I saw one guy's uh, presentation on it. He just spun the thing like this. He just moved it once like this, and the aluminum moved. And I was like, wow, that's pretty. That's freaking awesome, you know. But I really want to do this toroid gyroscope on the DC motor. Yeah, 486. I think that's moving pretty freaking awesomely. It's almost in sync, like 100%. Like I said, there's like about 100 RPM differential. So that's pretty sweet. And I'm just basically talking about electricity in and electricity out. Like the over unity principle, where you're getting more out than what you put in. I just think you got to factor in all of what you're doing to what you put in, and then reverse engineer that, and you're gonna get what what it is. That's what you're gonna get. It's like I was looking at the SG circuit the other day, and how you have the collector tip coming out with the diode on the end, and what that actually is, and what it does, and why it runs everything so well. And I'm like, it's a continuation of the energy of the input energy that is experienced zero, next to zero loss. It may have even been amplified, but it is an amplification. You gotta reverse engineer that. You know what I'm saying? You can't just have it dangling out there when you gotta do it to everything. The reverse engineering skill, you gotta apply that to everything.
What's up, James?
Not just what you want to apply it to. Not just what makes it look good. Apply it to that thing that's. And yeah, I've been checking out some of the solid state stuff too, man, and that stuff is cool. I like that stuff, but I don't see really. I see amplification, and then when you put the energy back in the other way, you go straight back to what you were at. You don't have anything extra. So, I'm not even worried about motion moving forever. If we're bouncing energy back and forth from one battery to another and nothing's moving at all, is that going to last forever? I don't think it will. It won't. Just traveling along a wire and to get the frequency to do the air shift, the air stuff, that's not free. Okay, it's not free. All right, running a Tesla coil is not free. Even if you do it with an SG, it's not free, because you've got to run that SG circuit, that verse 1. You've got to have it going in order for any of that other stuff to work. So, it's just, that's my logical breakdown of free energy. It's not. It's not free. It's awesome, and the stuff is cool, Everything looks good and everything is good, but it's not free. And it's not, it doesn't come from nothing. You know, it doesn't, it's just good. That's all I gotta say about it. All right, so with the expenditure of 10.1 volts and zero point 0.1 amps, and this is an expenditure in both ways from our nuclear power plant down the road. I'm taking power from that, and I also have to pay a bill because that power is actually taken by the power company or conjured by the power company, and then they sell it to me via this line right here. Oh my God, I'm blown away that that's happening. I'm not even gonna question it. You know, that's how things work right now. I'm gonna play along with everything. I'm gonna pay my bills, so I have the energy to do what I want to do. I'm thinking about doing batteries, maybe, but not lead acid. We're not going backwards in time, people. I refuse. But we may try different options. We may try more futuristic options that might be able to work as well with or better with SG than the lead acid. We're going to scope out different ideas. If it has to be that way, then it shouldn't be at all.
I've heard that sodium iron has a 12-volt battery.
Sodium iron, so we'll try that.
So not lithium iron, but sodium iron now has one.
Because again, just the rigidity, it's making my bones stiffen up.
I hear you.
And it shouldn't be like that. This should not be like that at all. It's just not okay with me. And we're going to find a way past it.
I appreciate your honesty and input on this subject.
What up, Noah? I wasn't looking up. Bro, failed to mention that you had arrived.
I didn't see it either. I wasn't looking up.
Oh. Yeah, all that's being factored in here. Laws of physics, freaking ratios, equations, mathematics. It's all being, I don't know what any of that stuff is or what it means, but it's all right here in front of you on display. And it's all real. There are no magnets on this disc. There's just a straight up aluminum disc.
We do want you here, Noah, very much.
I don't want anybody to go away, man. Stick around. We're gonna do stuff. And this is the thing, man, I don't have tools that will allow me to shape the length of metal of any kind. I don't have any of those tools. So we're not gonna shorten these poles. Not gonna cut a foot off of these poles. I don't have anything to do that with. You know, we're not gonna, I don't have a soldering gun or iron. I don't have anything that has anything to do with solder. And yet all this stuff is coming together in a slow and tedious way, but I guess that is, it's good, you know?
Yeah, you had your mind like, how can I spin this disc
Mm-hmm.
for a couple months, and look at it now.
Mm. So yeah, I was like in the middle of kind of building this gyro pulse motor. Really all it's going to be is a strip of aluminum, or maybe two strips of aluminum in a semicircle attached to that pole right there on the bearings. So there might even be a former involved. That will be attached to the bearings, but then there needs to be like a maglev of some kind keeping this aluminum ring away from touching the magnet, because the magnet needs to be free to spin. I think the former will be able to solve all those problems. The magnets need to be able to free to spin, the shaft needs to be free to spin, and then the gyroid thing needs to be able to spin the other way. Yeah, so one of two things are going to happen based on this demonstration right here when I build that thing. Okay? One, it's going to spin in unison and sync up with the rotor. But it's a north-south rotor, so I think what's actually going to happen is it might counter rotate. It just has to be free to do so. And that's how I'm going to build it, you know, so it can move around. Yeah, this rotate, and I just explained that it's going to be part of a gyroscope, tabletop, experiment, toy kind of thing, man. That's all we can do right now. Anything that you're thinking about building, like person-sized or anything like that, is going to cost you a fortune to build. And I've been just doing this for a year and a half, and I know that. Even if you're going to be like scrapping it and going to the junkyards and stuff, you're going to need to pay a pretty penny. You know, yeah, glue gun, although you're going to end up hating it, is your best friend. It's your best friend. It'll get you to where you need to go so that you can keep moving. Because if you get bogged down, you're going to quit. You don't want to get bogged down. It doesn't matter if you don't have your frickin' piece and it isn't coming for a month, you need to do something else. You need to keep moving, you know. Believe me, I know, man. Once that energy shifts, you gotta then you gotta pick yourself up off the ground, and that's like even harder to do. So yeah, I'm gonna make that former. It's probably gonna be a 6-inch, maybe less, maybe a 5.5 inch ring. That the aluminum will, I'll put the aluminum on the inside, maybe double loop it, poke a hole through it on each end, and then have the hole ready for the bearing to go in. And then I gotta sort out like how I'm gonna attach a maglev or just a magnet to it. This might be a good opportunity for me to experiment with other different types of maglev builds. Because you want to keep them separate, you don't want it resting on it. You know what I mean? You'll get what I'm saying. If you don't know, if you're around when I finish it, you'll understand. I just think this is awesome because this is north-south with a standard trigger drive, and it's moving better than it would be if it was all north. And then this, whipping along. So I have an axial flux design in the works. I might have to use a different gauge than this though, because this is 1.3 ohms. All this is 1.3 ohms. So, you know, even having 5 or 6 of these together in series, we're going to be like working at 6.5 ohms. And that's going to explode whatever I'm working with. It won't work like that. So, I mean, the shape is good, but I think I'm going to change it down from 22 to 26 gauge. Alright, so this is a north-south magnet arrangement. There are 12 magnets here, so it's north-south 6 times. This is a 26 gauge drive coil, 30 gauge trigger coil, bifilar coil. And this is an aluminum disc at 6 inches being moved by eddy current by the north-south arrangement and the permanent magnets. So it's actually moving it by permanent magnet motor. This right here is basically a Newman motor rotor hooked up to a DC motor that I also use to spin the aluminum disc. And they're about equal because of the cycle. Cycle just repeats itself. This is a full cycle, north-south. 1, 2, 3, you see? And then this is a full cycle, and it beeps 6 times. I don't know what the difference is, but I guess this is stronger, way stronger magnetic force than these little magnets over here. So even with the 6 increase, times 6 increase in frequency, I guess it is, because the cycle increases by 6. The purpose is, I'm making a gyroscope, man. And if you think it, I don't know what you mean by that though, but I'm making a gyroscope. You can't just blurt it out like that. Yeah, I don't know. Yeah, okay. And then we got basically another Newman motor type over here that the gyroscope is going to be built on. I really thought it was cool when I plugged in the motor and it worked.
Yeah.
And I had this thing going so fast on a video that it didn't look like it was moving at all. It looked like it was totally just still.
Yeah, everybody check out the latest videos on our channel. You'll be able to see that in detail.
Yeah, there's a DC motor over here, and I'm gonna use this motor to spin that gyroscope.
Hey everybody, welcome to the channel. Thank you for dropping in. This is Papa Bale, and we are working with pulse motors and eddy currents today. Leave a like, subscribe, let us know if you have any questions in the comments. Thank you for coming in.
Thank you. Really appreciate you guys. Keep it interesting. Now, just a few days ago, I was working with my homemade reed switch. It's virtually just an 18 gauge wire that's elongated, a little bit longer than ring wire here and that's 14 gauge, and it comes out right here, and you can hook up several collector clips to it. And then you just have one negative coming out, and you don't have to take up a bunch of space on your but I also have yeah, I'm not gonna plug that in right now. So what I would do, let me do it. All right, so we're cutting the power on that. What do you guys want to see, the reed switch, or do you want to see the parallel circuit? Oh, I got an even better idea. We'll hook up our sculpture setup. We'll move the... What's up? Oh.
Great job, Noah.
What was he on about? The same thing he was on about when I was even addressing it? I don't know. I wasn't looking. Probably for the best.
For the best.
I don't understand why everything has to have a purpose. This is not the Matrix.
Well, if you got an imagination helps create purpose.
No, you don't need a purpose to do this stuff. If you just want to like do a bunch of things, then my purpose is to have fun.
You're absolutely right.
And the people that are asking don't. Okay, cool. Asking the question don't think that's a purpose.
Right.
And it is a purpose. And I encourage people to do this if they have a passion for it. For magnetism in general, just you don't have to do a bunch of electromagnetism. See, it's working. Oh yeah. But you can. I mean, and this it branches off into 1,000 different directions. Hell yeah. And yeah, if you got a solid state operation and you're working with a rotor coil, that's awesome. That's awesome, man, and that's cool. I might even get into that myself. I made it's a 32 or a 36 point rotor coil, 2-dimensional. I think it's pretty sweet. And that's all I gotta say about that.
We got a video in the library. You can search for rotor coil, I think it was a 32 point in the title.
Yeah, that's it. All right. Now it goes spinning for a long time.
Mm-hmm. All right, I will. And I'm going to learn how to do it in real time, Noah, but I will make sure. Yeah. Oh. Yeah, that one you made the other night's perfect.
I mean, the free energy thing is so unoriginal at this point that, you could think of something more clever to say. You're going to Drop a troll bomb. Like something that'll get you kicked, man. Think like that. Drop a real bomb. No. Free energy. I wish, honestly, I wish that some of this stuff was more free. More free. Not free, but I mean.
So does that mean more efficient? So you're minimizing the loss? Is that what that means?
No, that means that it cost me less money to run that little thing over there.
Oh yeah,
That's what that means right now.
Got it. So deflation in actual kilowatt hour price.
Yeah, man.
Got it.
Don't just shy away from the grid, man. Make it better. Make it free. Make the grid free. You know, if you're gonna take anything over, take over the grid and make it free. You know, we're having a big wrestling match right now between, you know, decentralization and centralization, which, you know, capitalism is part of centralization.
Yeah, well, for sure. And zero marginal cost economics are starting to play a role.
Yeah, there you go, bro.
Yeah, in certain areas of the world.
And that's why a lot of people get into doing this stuff anyway, is to, you know, save a buck on their electric bill or something like that. Heat their own water, or do, you know, stuff I would not even consider doing. I'm not an electrical engineer of any kind. I don't work inside of parameters. I don't work inside a box. I will turn that thing all the way up every time until I blow my stuff up. I'll do that. But
so what do we have here?
this right here is the ultimate zipper formation. You got a traction here, right? Traction, the black triangles. And then you go straight across. And it's, alright, say this is north. North. Straight across you got north. But then it's repelling. It's repelling the magnets. Okay, so you don't have a double load on this disc, which is excellent. See, and then it switches, and then there's no load over there, and there's a load over here. So that allows me to do this. And basically spin it as fast as I want to, and it'll stay synced because it's got a zipper effect going on. Oh my goodness.
That's good data. We might keep track on the frequency.
What do we have for Chris's wedding at the club, yacht club? It was raw duck.
Oh yeah.
It was raw duck for that wedding, and that's good. We ate raw duck. It was so good. I never thought that a raw duck could taste so good. Very exquisite meal.
Yeah, that's.
He literally had it on the grill for like 10 minutes, and it was like this fat. So like the whole inside was like red.
Hey everybody, welcome to the channel. Thank you for dropping in. This is Papa Bale, and we're experimenting with pulse motors today, and moving this disc.
Oh no, that was an actual. I didn't. It wasn't intended for him. Yeah, no. That was just his name sparked a memory that I had, and that was it. It was really good.
I'm spinning that disc with eddy currents. So drop us a like, subscribe, let us know if you got any questions.
All right, so we're gonna spin this. Gonna unclip my clips. Well,
Hooking up the motor.
all right, we got there.
I moved it in a little bit.
Well, that's probably not good.
Yeah.
Yeah, I don't know. I think that's right. All right, I think we're good. All right, let's see what we got. That is really close. Kind of back it out just a little bit. We'll do it like that. So that's good. We're gonna move it in a little bit.
Hey, Peter, what's up?
Hey, Peter. Wow, that is really, really close. Oh man, ain't that close. God, it's just so irritating working with a surface that isn't flat. All right. Yep, it's all kind of falling apart as I move it around. Don't know how I got like that. So, I'll be done with this in a second. Now I need one of these up here.
Thanks, Noah. Appreciate you.
All right. Heck yeah, that's like right up on it, or as close as I want it to be. All right, so that's 3 volts in on a DC motor. up a little bit. All right, get a look at the, see if you can, what does it look like in the camera? No, the toroid.
Oh, this just looks like it's slowly spinning.
Yeah, that is moving incredibly fast. So that's about equal or better than the rotor that I had doing it the other time or just earlier. Yeah, that's about to blow a gasket. Yeah, I wish I had something more sturdy than these things, but we do not. We don't. That's what I'm saying, man. I don't have the tools to like shape what I have. I have a 3D printer, and I can make plastic and infuse plastic in what shape I want it. I can do that. But if I want like aluminum, I don't have a printer that will do that. I have to either buy the shape I need, or that's pretty much my only option is to buy the shape I need when it comes to metal. Heck yeah, Peter. That's my man. Hopefully you're going to the same place or better that I've gone to once I figured all this out. It's like permanent magnet heaven, dude. It's I still like how this functions. And everything I said about it is exactly how it works. Having all these be south and all these ones be north is key for the success of this. I'm like, you have to do it that way. Because if you get them both to attract at the same time, boom, man, it'll stop really fast. Heck yeah, the teeny magnets. As a matter of fact, I had these big magnets spinning a bunch of these teeny magnets at the same time on their own DC motors, which are DC generators when run backwards. Wow, it's hot.
It is.
It's like stifling. There's no wind. Where's my wind at? No, actually, you should come over here because I'm going to be talking about this.
Okay.
All right, so I'm going to take either a strip of half of this, like that much, or the whole thing, and I'm going to attach it on a former to the inside of the former, going around like so. Then we're going to spin the middle, and hopefully the outside will either spin the same direction or the opposite direction. I believe it's going to spin in the opposite direction. I believe that's the only way it can spin, but I might be wrong about that. Yeah, but I really want to get, there's two things that I need to design. I need to design the next layer disc, which I believe will be a 12 12 slot disc here that'll link with this 6-inch disc, this 6 magnet disc. Just like it links with this 12 magnet disc. And then the former for that Newman motor gyroscope thing in the job right there. And that's pretty much all I got going on right now.
Let us know if you got any questions, comments. Drop us a like, subscribe if you appreciate this kind of content.
Yeah, hell yeah, I lost 10 pounds this week.
Congrats on that. That's awesome.
Thank you. Which one would you like me to run though, Yami? This one over here? Alright, so we're using the north-south permanent magnet to rotate the aluminum disc. So this is a north-south, and this is an aluminum disc. This is the base layer of my magnetic sculpture. So we've got a 12 magnet 8-inch disc with the north-south arrangement. And we got all south on the 6-inch disc with the 6 magnet arrangement. We got all north on the other side, which is key because when one is attracting, the other is repelling. And the way you find that out is like north is with north, and then on 12 magnet alternating spread, the 180 would be north. And so as long as it's not attracting, you're good. And that's so that at one particular point in time you don't have more than one magnet attracting the center rotor. At least it went the other way.
Mm-hmm. Oh, it's hitting the stand.
Mm-hmm. All right. So, yeah, in the works is the next layer. So what I mean by layer is now that I've got the two going out the side, I'm going to have the next one be elevated and connected to the one going out the side. None of these should be connected to more than one other disc at one time. Except for the middle one, which it isn't. Like I just explained, it is not connected to these at the same time. It's connected to them at different times. And that's the only reason it works. And then this one I had hooked up in parallel. This is a 12 magnet spread, all north facing. I'm thinking about taking 6 of these out of here and making another one. I'm having 2 rotors with 6 in them because the 12 is crappy. It's lackluster. It doesn't do very well at all.
It's heavy.
It looks cool.
It's heavy because of the extra magnets, but
yeah, it's heavy too.
Yeah.
It's not that great. I mean, its max speed is probably going to end up being about 500, 600 RPMs. And
you think it in between 6 and 12 magnets is the best? There's a sweet spot in there.
Yeah, I tried 9. I think it's either going to be 8 or 10, or it could be 8 and 10. Either one of those would probably work rather well
for this design.
Oh, for the 120 degrees? is going to be either 9, 6, or 12,
Got it.
or 3. You can do it with 3, but I think 6 is going to be your best one.
But then 8 would have to redo everything.
Yep, 8 would be a different rotor. 10 would be a different rotor. 11 would be a different rotor.
Got it.
With 12, we'll do 12, 6, 3, 4, 2, and 1.
Boom.
So I was just thinking to myself, you know, as and I talked to Mike about this. To find a binary sequence for the number 369. Like what is it in binary? And there's a definite answer for that.
Yeah.
I was just curious, and I forget exactly how to use the rubric. I thought I knew exactly how to do it, but it ended up with 9 digits instead of 8. And I was like, that's not right. I did something wrong. But it's going to be like 0, 1, 0, 0, 1, 1, 0, 1, something like that. It's going to be like that. Real easy. And then once you got the binary sequence down, you can just plug it into everything that we know already. And then the new stuff will come a lot easier. And it's just that the idea that you can take something and you can decipher it in a different way. I'm not saying that particularly would do anything necessarily in an exact instance, but that type of principle where stuff like that is possible. I totally lost what I was talking about. I was passionate too. I was on a roll.
You're good. It'll come back, or you'll start another.
Passionate tirade.
Oh, I call it tangent.
Tangent.
Yeah.
You got to put it on a tangent, or it's not going to work.
But it's maybe not because it's relevant. So.
This one in the middle to electrical energy. I am not currently planning on putting any coils in on this. That is an option though. It's not in the game plan though, but that could change.
Hey everybody, welcome to the channel. Thanks for dropping in. This is Papa Bale, and we're working with pulse motor experiments today. Leave us a like, subscribe if you appreciate this kind of content. Let us know if you have any questions in the comments. Thank you for coming.
I'm gonna have to get some water.
All right.
Yeah, so it doesn't like friction that much.
Hey Splash, what's up? Check this out.
All right, that was 4 volts in the DC motor. Here's the motor. Just so nobody's like, oh my God, he did it. He made a motor that goes really fast. I bought that like 2 years ago.
Yeah. Thanks, Splash.
All right, I'll be right back. I need to get water.
If anybody has any questions, drop them in. And I'm going to keep away from the toroid so we get a closer look at it. Yeah.
All right. So I was experimenting with my signal generator the other day. I started at 1 hertz and I worked it up with a trigger involved. I had a trigger coil hooked up, so it would automatically kick on. And yeah, I think the lower hertz for this stuff, it works really well. All right. So what I'm thinking about doing, or for my next like experimental demonstration, it's going to be with the signal generator. And I'm going to hook it up to just this coil. I'll remove all the other coils, all the other stuff. And we're going to see if we can't change the frequency with the signal generator. I'm not doing that right now. That's something we'll do later. Oh wow, that tastes so good. Well, it's cold, so it's good. I had ice in the cup. So I was just thinking, like on this kind of tip, you know, how Hollywood and all its fantastical stuff might actually have a tip on this before a lot of people do. Or that's how it used to be. You know, like they have like something suggesting something in Hollywood, and then it would like happen in real life.
Yeah, I know what you're saying. Yeah.
That obviously means they knew about it before it was going to come out. I mean, obviously. Which means like the information would probably trickle there first because there's a lot of money there. They get the first hit at everything before everybody else does. But not anymore. I mean, everything's kind of changed in the more recent days.
Here, I'm gonna make. Do you want me to try to make a poll?
For
That's what I was thinking. If we had any question that we wanted to ask.
Not really right now. Not off the top of my head.
All right.
I think this is great. So it moves this way, and this one moves this way. So that is counterclockwise and counterclockwise. So that is not counter rotation. And I kind of knew that already.
All right.
Oh, you're probably not going to get much torque out of these. The ones in the center work well together to produce a torque. So I can spin all 3 of these with the torque created from this one. So yeah, and I don't have any way to measure torque, so I don't really care about torque. I mean, I'm not trying to crack wood. I'm not trying to do anything that involves torque. I'm not putting this in a truck. You know, I'm not pulling anything or lifting anything with it. All it's really got to do is move. It's just that I know I'm frustrated with myself because I don't know how to answer any questions about torque. There's just nothing to do about it. And so I'm like, okay.
I can't wait for, and then you're just gonna see something and you're gonna want to do it. It's gonna involve torque somehow, and then you're gonna master it.
Well, I'm pretty sure it's involved with all this stuff already.
Through that, yeah.
It's just I don't know how to measure it. All right, that's moving in too close.
That's an interesting question.
I don't know. I think they'd have to have a north-south arrangement on both of those discs for them to spin. I wouldn't be able to, not the north-north, but not the way they are, no.
Good point, bro. But possibly the center one only.
Could I spin this? Yeah, I could probably spin the center one. I could probably spin these ones. But with the permanent magnets, not the aluminum disc. Like if I just moved this motor in as is and put it in the center, I could move both of those discs. Just as is right now. But if you wanted me to take two of these, put it on the pole here, and put it in the middle, they'd have to be alternating on both sides. I'm pretty sure. I mean, I haven't necessarily tested the monopolar one over there on the aluminum disc yet, and it probably will spin, but probably not as well. That's what I'm guessing. Oh man, no, we can't do it.
You want some fan?
I'm thinking if we can move the aluminum disc over here, but then I gotta plug a bunch of stuff in.
It's okay. I can. We can watch some reconstruction. What do you want to call it?
You know, I think I'm just gonna move it over here.
Okay.
Oh wow, it's already moving.
I saw that.
Huh, that isn't gonna work.
Right, because of the size.
Whoops. It's amazing how automatically something becomes less fun when the magnets go flying around. Sometimes.
Sometimes. Yeah, they are. Let's see if we can get it back in there. Yeah, nice. Nice work.
We're just doing this to see if the aluminum disc will spin with the monopolar.
You gotta like hold it with your thumbs in the middle where those bearings are. Oh, they come out of both sides. Get over here. Yep. Interesting. So that widens the scope.
No, that was terrible. I mean, it works, but not anywhere near as good.
Oh no, but I just meant it opens up monopolar design into the future. But I hear what you're saying.
Yeah, no, you're absolutely right. If I maintain my current course and throw efficiency to the wind, then it definitely has a place.
But I hear you. Stay focused. You got your North Star. Make it happen.
All right. So, but yeah, it does actually open a lot of stuff here. Let me actually run this on a motor. We're going to set up a little Eddy coil right there. So I'd say, yeah, that works okay. And it does open some doors. What do you think? Yeah?
Not doing it.
I do. Alright. But I'm even thinking taking 6 out of there is going to be better than what it's doing right now.
That's a 12 meg
Mm-hmm.
monopolar.
So it works both ways. It works monopolar and bipolar. But I can get this one spinning like 3 times faster than that one using this same coil. So I know that the bipolar is way better. Alright, yeah, let's get that going. Let's get it going. Sometimes it takes a little bit for it to turn on.
Yes, I remember that. Yes.
I'm gonna make sure it's going in the right direction here. Tap meter readings.
Hey Brian, how's it going?
We just headed in the right direction. It's at about 300 right now. Anybody want to guess what this is going to peak at? Hey, Brian. Brian, you want to guess what this rotor is going to peak at? RPM wise?
We got a 700, we got a 1000.
Alright, it's at 438 right now. $515.
570-ish. 1200.
James. Oh, man, James. It's already gonna be, it's at 570 right now, I would imagine. $606 so far.
Input. Three 3.75 watt, something like that.
$688. 693. We're still climbing. What an acceleration phase, though. This is freaking amazing. Hello, Woody. I think it's going to be about 700. Maybe not. 697. Alright, so we're going to start by turning it down. See if we can get it to go faster by turning it down. Hey, beat. So we'll start by cutting it to 12.5 even. No. I mean, yeah, it's going up now. Holy cow.
Alright, it's going up.
708. No, I believe I have one that'll hook up to an Arduino though that I don't know how to use yet, but I can probably learn it pretty fast. Just never bothered doing it. I can do all this without that. But I do want to get into using that. Absolutely. 714. $715. Let's cut it down to 12 volts. 727. 728. 731. Alright. So we'll give it a minute or so and we'll see where it's at. Well, that feels like it's really roaring now. Let's see where we're at. 733. So between the 12.9 and the 12 volts that I have now, we have not lost or gained any milliamps that are registerable. So it's been 0.3 across the board. I'm not going to adjust the volume any more than I already have because we're trying to do something here and I may have already jeopardized that. We've already capped for the previous voltage. It's 736, 735. Yeah. So it's about 700. That's it. Who said 700? That's a win.
Splash.
Splash with the victory. So I don't know. I got an idea though. We're gonna start fresh with a fresh trigger. And we're going to start from 9.5.
9.5 volt.
Like a 9-volt battery. That's good. 9.49. Very good. So drawing 0.1 off the 9.5 volts. Right on, Brian. That's what we're going to do this time. So basically starting with a 9-volt battery, we're going to work our way up to a 12-volt battery or maybe less, maybe a 10-volt battery. But yeah, probably a 12-volt battery. Nice, 500. Currently, what I'm doing here is I'm stepping up the voltage. We're trying to get, let's say, 1,000 to 1,200 RPMs out of this thing. It's a 12 magnet rotor. This coil is a 911 turn. 26 gauge and 30 gauge coil 5-filer. I just hit it. I hope that doesn't screw everything up. 615.
Nice.
This is a stand holding an aluminum disc, which I put up next to the north-south arrangement of magnets. And it'll start to spin. But I'm not going to do that. We'll put a load on it. I'm not trying to load it down right now. Yeah, I've wrapped a pretty small gauge coil before. It was more like a spring size coil. 718.
Yeah. That's close to where it was.
Yeah.
There we go.
I got 14 gauge that I use standardly pretty much, and it pulls a tremendous amount of amps. So it's like finding components that go with that is kind of difficult. $722. That's about capped, I would say. You want to give it 0.25? So 9.75. Perfect. Well, I have my amp turned up all the way, so when it needs amps, it'll take it up to 20 amps. So it's 750.
Okay.
It's not going above 750. I don't know what we should do. Should we go
Up to 10?
up to 10?
Because that was higher than it was.
I am currently, we're trying to reach 1,000. Nope, that's the wrong way. All right,
Okay,
let's turn it
so-
off. Turn it all the way off.
Yep, so
We're gonna so changing the voltage doesn't appear to help very much at all. So we're gonna pick a voltage and we're gonna set it off. And when we peak, we're gonna take that reading and we're gonna see whether we go up or down from there.
okay. So where do you want to start when we're ready to start?
10 seems like a good place to start. 9.5 was good, but
All right.
we've already done it. So, and that's going to be about 750. So we already have a reading at 9.5 volts for 750 RPMs. All right, so let's do 10.
10.
I am logging it. Huh. Let's write it down though, just for.
$7.50. There it was. And then we're gonna get the 10-volt marker right here.
No, this isn't it. We're gonna see which way it's going.
Oh, if it's up or down from there.
So this is 308, 400. Yeah, we're still going up by a lot, like really fast. So you're checking the time of your acceleration phase. 500 coming up here very soon. 510. 530.
Hey,
550.
Hey Cody, thanks for joining in. We are working with pulse motors today. Electromagnetism experiments.
Thank you. Yeah. Alright. 686, 693, 698, 704. We're still rising at quite an extraordinary rate here. We're gonna get this reading, and then we might screw it up like that. We're gonna wait till it stops increasing before we do anything. 740. Oh, we might be there at 740. So that means 0.5 volts of an increase results in 10 RPMs less. Alright, so
Definitely looking to have fun here, Cody, and
10
we
volts,
appreciate when the community gets involved,
40
and
RPMs.
we love to collaborate.
I like collaboration to a certain extent.
True that.
I mean, I like throwing ideas around and stuff. As far as that goes, collaboration is awesome.
You want to try and go 15?
Yeah, let's stop it.
Because we got a 16.5. You want to try it?
Yeah.
All right.
We're gonna do all that. We want to do 15.5 first and then do 16.5? Or we just want to jump to 16.5? It's 15.5. And we'll do
It's very strong.
17.5 volts. Alright, 15.5, bro. Yeah, we don't have a set voltage, Brian. There's no set voltage or amps that this thing requires. Those numbers don't exist yet. Alright, here we go. 15.5. I mean, if it'll run on 2 volts, I'll run it on 2 volts. That's how I feel about it. But I know there's that, what you call a sweet spot. Where, you know, your little bell curve. Like this, it starts, this is 0 right here, and it starts, or it goes like this. Well, whatever, I can't.
Oh, you got it.
Look at
We got
myself
it.
do it. No, I didn't get it.
The bell curve. We know. We got the bell curve.
It's not really a bell curve though. It's
Okay.
just a potential curve.
Got it. Yeah,
All
here we
right.
go. 0.5.
This is going 335, 340, 350, 360, 70, 80, 90, 100. So we're at 400 now.
Nice.
Yep. Yeah, the amp draw is open to 20.0. We'll actually flood like 22 amps. If it needs it, if it calls for it. $589, 600, 621. This is nice. 631, 641, 650. Nice. Looks like it was slowing down though. Slowing down on the rate that it was speeding up is what I mean.
Finding it at speed.
Yeah. 731, 740, 750, 760. Here, this is it, man. This is the bell right here. 766, 776, I mean. 800. I would not make a good auctioneer. No way. So we're getting there. We're getting there, man. We gotta still try out 2 voltages though. I don't think we're near our peak yet. Honestly, we're still increasing at quite a rate. So 850. We're going to be with 30 seconds. 1, 2, 3, 2, 3, 3, 3, 2, 3, 3, 1, 2, 3, 3. 857.
8:57.
Alright, I'm gonna mark that down. Let's stop it.
Thanks, Pete. You're a great auctioneer.
right.
21.3. Holy moly.
You want to do 20 volts? You just step it up, or you want to do the 17.5 intermediate?
Let's do a 17.5 and then we'll.
Okay, we're doing 17.5. We're looking for 1,000 RPMs, in between 1,000 and 1,200 RPMs from this rotor, north-south, one coil. Here we go. 17.5.
And Woodsy is the
Doing the same thing?
calculator right now, yeah.
Okay.
So he's confirming the jumps. We're just making sure we're getting the right numbers right now.
Okay. That's awesome. Yeah, this is actually kind of fun. Real science here, ladies and gentlemen. We got our constants. We got our variables. And we're going for it.
Yeah, you gotta be very sensitive with this guy.
All right. That's fine.
Okay.
That's fine. That's fine. We're going to do that next, Woody. Here we go. And then we're going to, let's make it 22.2.
Okay, we'll make it 22.2 on the next run. And it's 3:33 p.m.
That's awesome.
Just turned 3:34. We want to thank you guys for 100 subscribers today.
Thank you.
And please like and subscribe.
Thank you so much. Really appreciate it.
You guys being here helps support the channel, and we're looking to have more fun with our experiments.
The reason the pickup is so long is because it's 26 gauge. So there's lots of resistance, lots more resistance than over here.
And the answer up.
574, 600, 620. Wow, that's increasing at a very steady rate. And I like each run for it to get a fresh start, a fresh trigger. That's what I'm talking about from the start, before it's triggered. I want it to get a fresh trigger each time. Yeah, that's right.
That's right. And Palo Santo.
Can't be too careful. $8.15. Starting to crawl up slower and slower. I think we've reached the top of that curve. I don't think we need to go to the next level, but we'll see what happens. We're going to do that for sure.
22.2.
Yeah. 824. This is it's a pulse motor. It's hooked up to this transistor right here. It's a simple one from, it's an M.P.H transistor with BCE pin layout. So you just hook that up to your 30 gauge trigger, which is to hook up to the resistor. And you got your 26 gauge drive, which is making this thing spin. And then your transistor does the timing along with the sensor coil, which is your trigger coil. $820, $821. Yeah, that's capped.
Okay.
Let's turn it down or off. We're gonna put down 825 for this one. Looks like we're going down in RPMs currently. So I'm thinking it's somewhere in between. It's gonna be 16.5. Whoever said that probably got it right. Yep, 857. Now we're down to 825 with the 2-volt increase. So here's the question. Do we want to go up to 22 or do we want to go down to 16.5?
21.3.
All right, let's try 21.3. Let's do that. Yeah. Thank you, Joe. And we're just having fun, man. We're like having a little race against itself right now. And we're actually finding the optimal. Oh yeah, 21.3. Right. Nice. All right, here we go. On your mark, get set, swim. Oh, that was a lousy one. It caught though. It's gonna take a while. Should I spin this again? Looks like it's gripped it, but I don't know, man. Should I spin it again? No? We're good. All right.
Right. Amps climbing.
Yeah, that's because this thing is slowing down. Doesn't look like it's slowing down, man.
Faster start speed, yeah. You want to, yep, you got it.
Oh yeah. No. This thing is starting to piss me off. This tachymeter. No, it seems like it's slowing down.
Mm.
Here, turn it off. We gotta start it fresh.
Okay.
Turn it back up to 21.3. Yeah, my finger slipped out of the hole.
Yeah, that's a 12 magnet.
Yeah, let's try it again. We probably could have sat here for 15 minutes while it caught back up with itself, but we're just gonna spin it again. Yep, that's good. All right, here we go. I'm gonna give it some time now. I think that's the winner right there.
Yes, sir. That is flying.
Yep, and our amps are not crawling up right now. That's how I know it's going. It is slowing down.
So we got a suggestion to turn the actual coil
That's not going to help this.
in the
But that
direction.
might help it run better, but it's not going to help this current situation. All right, turn it off. Yeah, that's hot. That coil is hot.
It's hot.
That's probably what the problem is that it's overheating.
Thanks, Pete. Appreciate it.
Yeah, all that current. Yeah, this isn't gonna.
Oh, just move the coil back some. It may be.
No, listen, man. Moving this coil at all is a great undertaking.
Do you need an oven mitt?
No,
Just play.
it's just not a simple task. You can't talk about it like it's a simple task. It's not. Just move it here. No, it's not like that. I need more glue. I need to move it back. That's what I need to do is move it back. And then these are on there permanently. Those gray things are never going to move.
Got it.
And that's lined up perfectly, man. Look at it with the camera. What's wrong with that? Was it not like that? Did I fix it?
I'm not sure. We'll wait to see if we got any more suggestions coming out.
All right, let's try 16.5. Because I think above 20, it just lets go. There's nothing, it's not pulsing anymore. And I think I remember doing that experiment earlier. So like the highest we should go is 20 if you want it to work at all. All right, here we go. And I was bummed too, and I was like weirded out. I'm like, I'm turning the voltage up, it should be going faster, right? No, not with this stuff. Gonna need to get a new battery for the tack meter.
Nice. Means you're using it.
See, but notice the amp draw over there for 16.5 is the same amp draw for 15.5. So I think this is our number. This is what this is going to be a winner right here. Because we actually get that extra volt without increasing the current rating. Which I would say equates to more speed. But we'll see. We'll see. $641, $653, $672, should work that way. Where you turn the knob to the right and it goes faster. That's what it should happen, but that's not how this works. This is not a motor like that. 820. Oh, we're climbing. It's weird because I got 1,000 RPMs off 10.1 volts. And then we do it with this like it is and we get 740. I mean, and it's not always like consistent. This stuff is renowned for its inconsistency, at least the way I do it. I'm starting to see the benefit of getting all these numbers lined up. That way you can kind of plan out whether you're on the right track or not. $872. We got a winner, folks. It's not done yet, I'm sure. No, just totally less power. Not less voltage, more current, nothing like that, man. I'm talking about turning the knob to the left, the amps and the volts go down, and the speed goes up. And I don't know why. I have no idea why. I have no idea why that happens, but it does. It really, really does. And I'm like, I don't understand. But there's definitely, with resistance and impedance and reluctance and all this other stuff, man, it adds up to a sweet spot.
Temp at the coil, that kind of stuff.
Yeah, temperature of the coil, whether the enamel's melting or not, is important. If you got cross connections, you're going to get it's bad coil. $872. All right, let's cut it. We're gonna do this one for $872. How much was it? 16.5.
16.5.
Just for giggles. We're gonna do two more. All right, we're going to do 18, and we're going to do 16.
Okay, the in-betweens. Where would you like to start, sir?
Start at 16.
This is a coil. Okay. Here we go.
Yeah, definitely having the less powerful magnets has made this possible. With these powerful magnets, I haven't been able to do a north-south rotor. They just... Haha, true that, Bear. Or beat research. That's exactly where... Beaten where? There. That's where it came from. Beat where? Bear. All right. You ready?
Ready.
Mark, set, go.
Hey everybody, welcome to the channel. Thank you for dropping in. This is Papa Bale.
Hey, what's up?
We are working with pulse motor experimentation this afternoon. Please leave us a like, subscribe, and let us know if you have any comments. Thank you for coming.
It might have been that it was closer. The coil was closer in the experiment that I did, where I got 1,000 at all. I mean, it was closer. But that's weird because normally you get a little bit of a speed boost when you pull the coil out a little bit. So I don't know.
Welcome in, NC.
ANC 650, 666, 675, 687. I have to get some more water soon.
What's up, Jay?
NC mat, brushless. Very true. It's a north-south configuration. I don't know how it's working, but it's working wonderfully. $7.58. I'm gonna get that water right now.
Okay. That's 16. Oops, sorry, finger. We're letting it speed up. We got up to 872.
Ice straight from Greenland. Only the best ice. It tastes magnificent on my throat. It's cold. Cold ice, ladies and gentlemen. 877.
877 on 16 volts. Oops. South Carolina in the house.
What's up?
We are in Metro Detroit here.
Alright, so we're going to take one more of these. We're going to try
North Carolina in the house.
$875. We'll give it. It's about the same.
875.
That's 6.5 volts. 16.5 volts.
Okay.
16. 877. All right, we got to do another page. Turn it off, please.
Turn it off. Off.
Wow, that is hot, ladies and gentlemen. Go ahead and try this stuff at home. That coil is hot, hot, hot. It's not like scalding hot or burning hot, but I wouldn't want to hold it for very long.
This is bipolar here.
Yeah.
Coil is still hot, yes. Oop, finger, sorry.
All right. So I wanted to do 18 volts, right?
18.
Do 18.
Yeah.
Yeah, the freezer box. We're gonna call it the learning box. Where we learn that nothing is free. You ever heard the expression throwing your back out? Nothing is free, ladies and gentlemen. Nothing is free. All right. Here we go. It's not necessarily that everything has a price, but everything has a cost. So, I mean, if you can differentiate the difference between the price and the cost, you'll understand more so than if you just think that if it doesn't cost anything, it's free. Like, if the price is zero, then it's free. That's not true at all. If the cost is zero, then I'd have to just tell you to reanalyze what you've discovered. Do some reverse engineering. You're going to find out that that is not the case. There is a cost. You just don't know what it is. Everything's got a cost. I mean, the ether has a cost. There's an equal and opposite dimension to the ether. It's called nothing. Okay? For everything out there, there's a nothing out there. You know what I mean?
That's a good point. For every something, there's a nothing. An equal and opposite nothing?
No. Something, something, and everything. Or something and everything and nothing are on the same spectrum. Something,
Yeah.
and I don't know what the other opposite of that spectrum is, but it has nothing to do with everything and nothing. Absolutely nothing to do with it.
Yeah.
Something is something else. $781, $785, $793, $800. We're moving right along with 18 volts, ladies and gentlemen. Pardon my opinion, my ranting and raving, but it just seems to me that none of these things would work. I mean, bats wouldn't be able to see because they wouldn't have sonar, because it wouldn't work. You know, if there wasn't that equal and opposite reaction to your action, then these things wouldn't work. The only reason my buddies can concede is because they screech at something and it bounces off of it and comes back a detailed image of what that thing is. And it only works because there's an equal and opposite reaction to their action. And it's the only reason that it works. As well as it does. Because it's not really even a law that you can't break. It's just a discovery. I don't know. We're going to have to redefine and reevaluate the way we feel and think about things. You know, AI is definitely going to be helping us in the future here.
I believe it.
Without a doubt, man. People are already leaning on AI. And AI isn't even AI yet.
Right?
You know what I'm saying?
Mm-hmm.
Doesn't think for itself yet. No, it doesn't.
Trying to get it all in one angle. There we go.
776. All right, turn it off. It's too hot. Turn it off. Yeah, hell yeah. It stopped moving. All right, we're not gonna get 1,000 today because it's too hot.
So we'll have spare coil next time.
Yeah. That kind of sucks. It got going around 815, and then it stopped. Its teeth, it ripped its teeth out, and it was just trying to eat steak without teeth. And you know how that goes. I love this motor right here.
That's sweet.
Yeah, it got me going, man. I mean, I had it hooked up to one of these rotors that was hooked to the shaft, and I got it going. I got 400 AC volts off of that without a problem.
Nice.
I'm gonna have to get a whole new table, a whole new design. This doesn't work for me anymore. I used to be really Johnny on the spot with where I would put my coils. It would be very nice and neat. And just having this black on here that wasn't good to begin with. Because if it's brown and you rip up a piece and it's brown underneath that, then you can't really see it that well. But this is just a mess. And if you go back and you look at some of my earlier videos, you will see that it doesn't look like this. It's really frustrating. Not to have to clean up. It isn't about cleaning up, man. You'd have to go through like 10 Sharpies just to cover this up.
Yeah, that's true. I think if we get some sort of like plastic, something we can screw into. I think maybe even the plywood would work, but we'll figure that out.
Yeah, we're gonna try all that stuff.
Okay, plastic pegboard. Oh, pegboard. So I think it might be the same. We'll look into that too, yeah. But something that won't bow, because you can see how the weight in the middle.
Yeah, that's just one problem with it. It's really a cosmetic issue, honestly. And all I need to really do to fix it is flip this over, take it off, flip it over, or leave it the way it is, and put this one on. Top of it perfectly lined up. It's upside down. So it's brown on the other side. But, yeah, but what I really wanted to show you all before I got distracted was the motor. Yeah, don't. I need to go back over there. Oh, shoot. Good looking out. Sir. You're on top of the game tonight, sir.
Yeah.
I was just warning you that I gotta go back.
No, that's good. Placement. I don't want to be standing where you're standing. Now try to walk around.
All right, let's put it up to 9. Oh, wait a minute. 5. 15. My fault.
15?
Yeah, 15. We're going to make this sculpture motor move on with this one coil. That's good. Yeah, here we go. Now, if it gets synced, it can get up to like 500, 600 RPMs all together. You know, they'll all move at the same speed. Or it'll stop. But I've gotten it to move before. I think it's still moving.
Need more voltage.
Oh, we'd have to start it and stop it again. Go ahead and stop it. 16.5?
Yeah.
So I'd say, yeah, that works pretty good.
That looks sweet.
And if I wanted to make this into an extensive pulse motor, I could probably do it. Pulse motor generator, something like that. But that's not what it's going to be. It's, so it alternates here on push and pull. It pushes and pulls both discs, but at alternating frequencies, so it's always only doing one or the other. It's never doing both at the same time. What gave me that idea was the 0-1 pulse motor that I have, the 9 magnet rotor, and you put the coils at 180 degrees, and then one's always hitting and one's always not, kind of thing.
All right.
You're still moving.
Oh, my bad.
Oh, you can turn it off. That's good. We got the point across, right?
Yeah.
And then, you know, you can spin it. But if you jerk it, you know, if you like whip it, then they don't necessarily stick. If you stop it, all of a sudden they'll keep spinning, you know, normal stuff. But it gives it a great grip. I mean, this grip is phenomenal. It'll go back and forth. I mean,
Yeah.
you want to stop it first, of course.
That's impressive.
And it's just getting that proper sequence. It's just alternating in the middle and then all north on one side, all south on the other. And then bam. See if I can just jerk it like I just jerked this one.
Yeah, I see it.
But this one will spin all those two. This one will spin those two. Both ways. It will spin. I'm going to make it so each disc on this thing will be able to spin any of the other discs anytime. At least that's what I hope. I'm realistically, that's probably not going to happen, but we're going to try and get close. Oh man, I have a video of a prototype of this to show you exactly how it's going to go. There's going to be like one here, one here, one here, and then one on the pole over here. And then this one will be one here, one here, one here, and then one on the pole over here. And that'll be a segment. And that segment will be complete. It's going to go up. It's going to build up. So the poles have to be long or longer. Will it flop around without top stabilization? I bet $1 million it'll flop around. All right, but yeah, I think we've gotten a lot of information out today. We've been got a lot of ideas in today, and we're gonna call it here pretty soon. I am definitely looking to sit down.
You want to talk about the memberships?
Yeah, we got 3 levels. Student, apprentice, and master. The student unlocks pretty much everything. Master gets you a free print on the printer there. You can throw me an idea. That free print renews once a month, so you can get. But of course, you're gonna have to get to know me and know where you live and everything. Okay though, right? A P.O. box, I don't care where I send it. I'm just saying I'm going to know some of this information if you want to do that.
Thanks.
So we got and then you get access to the workshop in the Discord channel, which you get for student membership. So student membership will get you the Discord, and then master membership will get you the password. And what we discussed in there is pretty much what's gonna go on with my life for like the next however long. Because this is all I'm doing right now. I'm doing this, I'm driving my car around, and I'm watching kids. Pretty much that's all I do right now. So yeah, this is gonna be pretty awesome. I'm about to go spend some time with my kids though. We might set up a field. Like those solar fields in the desert, except we're going to do it with this. We're going to have this in the middle. We're going to have it surrounded by a bunch of little ones. And basically, I'll show you. Spin this. Look at this magnet right here, bro. See how it moves? Doesn't need to move very much. Doesn't need much power to move it.
Yep, got it.
And then you move it in closer and it moves a lot more. You move it a little bit farther back and it'll still move it. Okay, so you got all this range around this toroid magnet where you can place it. And it's better to place it perpendicularly at 90 degrees. So one here, one up here, one there, and then maybe move it in so you get like 8 or 9 of them. The offset ones really don't move that well. They don't. Not much you can do about it. You can complicate this. You can complicate this. I mean, you can give it more sides, more faces, more north-south if you want, but it's complicated things. Okay, you just want it to interact with these on a one-to-one basis, north to south basis. It'll spin fantastically. You don't want to complicate things. I have extensive experience with complicating things. You don't want to complicate things. I speak from experience. This is as simple as it gets. And it works better than anything I've ever done in regards to the magnetic sculpture that I'm building. This is the link right here. Now, I've had ideas of what could work better, but I honestly don't think it's going to work better because this way you get the one-on-one. See, it's attracting here, it's repulsion here. Okay, so every time these turn, you're never getting double attraction. Double attraction is what's going to stop this thing. And I mean, with the fluid motion and the lack of the double load on the rotor, allows it to sync up at high speed, like 500 RPMs or more. Oh, wow. What a day. Thank you all, definitely, for coming through. Hey, Brian, I got a question for you. What am I 120-degree offsetting?
Let's see, you did try that.
It's been up there for a while, but
The pulse coils. Okay.
yeah, I don't know. There's so much going on the table. That's not good info.
If you
Over
do two,
here?
if you do two, in this one right here, two in that one, two more.
So you mean like having? But you said offset. So this is a north face,
Oh, and then have one on the south face.
then have two on the south face, like this. Is that what you're saying?
The single magnet ring. This one.
Yeah, that's not going to change.
Okay.
Yeah, no. I just got done explaining how I wasn't going to complicate this. It's all good. It's all good.
Oh no, my bad. He was talking about that one. So didn't you have two set up at one point?
On this?
Yeah.
No.
Okay, only one so far. Okay.
But this one looks ready. But we don't have anything to put it on.
Yeah, we need to print out a stand.
And I really want to try like putting some coil over here. Maybe a coil on that side too.
Oops, finger. There we go.
But yeah, we could definitely put it here, which would be offset.
Yeah.
But, you know, it can't really go there because the next disc is going to go, it could go there. If we can make it go there, that would be good. But it's going to go like right here. And there's going to be a pull like this, probably going right about here. I guess we could make that work. That'd be awesome. But yeah, if I need more power, I will find a way to make that happen. And that's just to get the 1,000 RPMs, I understand. But it's weird because I've already gotten 1,000.
Yeah,
More than 1,000 with this
like
rotor.
on the video.
So it's probably because the coil melted. The coil melted. That's literally probably what happened. It was that hot that the enamel could have just melted a little bit.
Yeah.
Not through the whole thing, but enough to make it short out. Oh, you mean, I see what you're saying. Like this. And either have one on each side or just the one. And then I think that would work great. Heck yeah. I think I might have to get something to eat. I haven't eaten all day.
Me neither.
And I think I'm on a roll here. I think I lost 10 pounds this week.
Congrats.
I got a huge stomach still, but dang, dude, that's a lot of weight.
Congrats.
Yeah, that coil, like when I move it, I'm probably not gonna put it back. This one is what I'm talking about. This one is not gonna move graciously at all.
It's a tear down.
Yeah, that's what I'm gonna do that when I'm done with it. I think I'm going to take 6 magnets out of this rotor and build another rotor with it.
Nice.
I might build a 4 and a 2 and a 6. Utilize the magnets the best way I can.
Yeah.
All right. Wow, I'm exhausted. Hell of a day. Said it for the 3rd time, I think.
Well, great stream. You got a lot done today.
I think so. I do think I'm going to pull 26 gauge for this type of coil out. This is 22, and I think it's just a little small. It's only 1.3 ohms. This whole thing. So.
You want to do a recap of some of the things we did today?
Oh, you mean back them out a little bit? Yeah, this one isn't, I've already done that. Like as much as that one's going to back out. But I'll rip it up here for a second. Are you talking like that, Brian? Yeah, like this. Yeah, I need something to put there.
I found them.
Sweet. We might be able to get both on that. never mind.
Excuse me?
I forgot the stand was fastened down there.
I don't know what you mean though. This is gonna be perfect.
Yes.
So what are you talking about?
Angling the thing like that and getting both on there.
What thing?
Angling this like that so you can get both of the coils on there.
Why would I need to do that?
That's just what I was talking about, bro.
Oh. Okay. Alright.
And he's saying tilt them in the direction of the spin.
So you mean like that?
Yeah, something like that.
Look out.
Coming through.
Coming through.
Yes.
Excuse me. Yeah, I did an experiment like this back in the other room.
I remember that. Oh, and the V1.
Yeah, the V gate, what I call the V gate, because see this V that's shaped right here? That's why I called it the V gate. But it was not the same as whatever everybody else was looking at, for sure. Now you do know I need to get a transistor and everything hooked up to this.
Okay.
Yeah, no, I'm not really in the mood to do that.
It's okay. We can take a break and do it later.
You okay?
Yeah.
Alright. But we can run this one on the transistor that's already hooked up.
Yeah, he said try with just one. He's eager to see it.
Now is that too close now?
Let me get right over it. There we go. Give it a spin.
Well, I'm going to turn the power on in a second, but...
Okay.
Yeah, I'm kind of wanting to hook that other one up now.
Mm. Oh yeah, trying to read small stuff.
Yeah, like the stuff that, I mean, it's not just small, it's shine, seen.
Right.
have no idea how. Yeah, I don't know about this.
Hey everybody, welcome to the channel. Thank you for dropping in. This is Papa Bale, and we are working with pulse motor experimentation this afternoon. Please leave us a like, subscribe, check out our memberships, leave us a comment if you have any questions about what we're doing.
I got hopefully some good MPNs coming from eBay. Hopefully. Good ones.
Trying to get your circuit work on the close-up.
Yeah.
It's good. You're doing a lot. I just don't know if they can see it all.
It's good. Good for me. You don't look that attractive right now, so.
Oh,
It's all right.
you can be a hand model.
No. All right, so that's good. Let's get there.
Yeah, they do.
All right, now I just need. I'll just take this one for now. Watch it go straight up on the amps, and that means that it's a bad transistor. Let's make sure. Alright, so one is going to be hitting the north, and one's going to be hitting the south, and then they're going to alternate. Do a 9 volt or 10 volt, 10 volt. Oh, we're drawing.
Or 2.3.
No, we were drawing before we started it.
So
it's
that's
probably not good.
Okay, got it.
But I think I might have found an answer to that. But it was just one.
Try to.
Nope, it's a transistor.
Okay.
So the one is working. This one is working. This one is not working.
Alright.
This transistor is not working the way it should be. You're not supposed to be able to draw amps before you trigger your coil. It's just the way it is. That's how I gauge whether my transistor is working at 100% or not, whether it's drawing amps before I actually move the thing. And how high those amps go. And I don't feel like looking it up 100 times to figure out which one of these transistors is working. So, that would have been really awesome to see. Maybe we'll see it the next time. I got transistors inbound that should be good. But yeah, there's probably 2 or 3 good ones out here. Could try this one. And then we're gonna call it a night, okay?
Alright.
Alright,
Excuse
here we
me.
go. Nope. Damn. Sounds like they're both hitting though. Alright, that's awesome. Well, it didn't like go the way I wanted it to, but that's okay. I'm sure that if I mess around with that a little bit more, it'll be exactly the way I want it to be. And the next time I start this, I'm going to start it with this one. Oh, oh. Oh. Dang. There it goes. Huh, so I wonder what's the difference. I think the only difference is the distance of the coil from the rotor. Alright, well, don't know really what's going on here right now. I know that if I whip the middle one, those two spin perfectly. And that's all that really matters, because the middle one is where the motor is going to go. Alright, so for the next stream, I will have at least one disc of the next layer built. And that will happen before the next stream. So thank you. Thank you very much. Peace out, ladies and gentlemen. Please sign up, subscribe, hit the like button. Join us for our continuing live stream adventures. And yeah. Thank you. Bye now.